Hi everyone, this video is going to be looking at naming organic molecules and specifically looking at organic molecules that have functional groups that can be found in varied locations. That is to say, they might not be always on the first carbon or on the last carbon. We can really find them anywhere within the molecule, so we're going to be needing to use numbers in their names to denote where they are within the compound. I'm going to be looking at 4 different classes of organic molecules, all of which can be found on Table R. So I recommend as you watch this video, you have Table R out as a reference. I'm going to start with the halide class of organic molecules. And as you can see over here on the left, I've got a 4-carbon molecule with this attachment or replacement fluorine atom stuck onto it. So when I'm trying to get a name for this molecule, what I'm going to do is first think about the prefix that I would use. I see the prefix but in blue over here, denoting that I must have 4 carbons in my molecule. We know the suffix ane from alkanes. This means that this molecule is connected entirely by single bonds. That just leaves this 2-fluoro piece at the very beginning, and that's going to tell us what modification we've made and where. So to my original butane molecule, I have stuck on a fluoro group, which from Table R you can see relates to a F, or a fluorine atom. And I've added that F on to the second carbon. So that leaves me with my end name 2-fluorobutane. Let's use those same principles to try and break down this second molecule. Right at the heart of this molecule, I've got 3 carbon atoms. And I know using my reference table that the prefix for 3 carbon atoms is prop. I noticed that all those carbons are connected by single bonds, so I'm going to get my core name of propane. What I see though is that this propane molecule has been modified with an attached Br. And looking on Table R, I notice that when there's a Br functional group, I use the prefix bromo. So I'm going to have bromo in the name. And then I just need to tell my reader where that bromo functional group has been stuck on. And if I'm numbering to try and get to the lowest number, I would go from right to left, leaving my bromo group on the first carbon. So I see at the heart of this molecule there's prop, single bonds, with a bromo attachment on the first carbon. Let's use that same analysis method to look at this molecule, 1-chloropentane. If we're going to try and draw this, I want to break it apart into its component pieces. I'm going to highlight that pent prefix because I know that that tells me I need to draw 5 carbons. The ane suffix tells me all of those carbons will be connected by single bonds. That means this remaining piece must tell me what my modification is. And looking on Table R, I see that the chloro prefix means that I've attached a Cl group, and that 1 tells me it needs to go onto the first carbon. So you can look either at this one or at this one, depending on which way you're numbering. You can stick that chlorine on the top, on the side, on the bottom. It doesn't matter. As long as it's stuck to the first carbon, you're going to be good to go. Fill in the remaining molecule with hydrogens, and you've drawn 1-chloropentane. Let's use that same kind of analysis to look at a second class of organic molecules, the alcohols. Right? On the left, we've got, again, a 4-carbon molecule, so I expect to see the prefix but show up in my formal name. Those 4 carbons are all connected by red single bonds, so I'm going to have the ane within the molecule, but you'll notice that the E has been changed to something different. This remaining 1-ol must tell me how I modified my original molecule. And if I look on Table R, I see that the ol ending is unique to the alcohol class of compounds. So what that means is that I must have added on the alcohol functional group to the first carbon. So using Table R, I know that the alcohol functional group is OH, and sure enough, on the first carbon, I see that OH sticking off in the place of a hydrogen. So that's how I'm getting to that name 1-butanol. So if we use that same logic, we should be able to name this molecule here. I see at its core, it's got 3 carbons, so I'm going to write my prefix prop. Those carbons are all connected by single bonds, so I'm going to get my ane but stop because I know I've got this alcohol functional group sticking off of my second carbon. To tell my reader that that's what's happening, I'm going to use the OL ending, like all alcohols have, and then tell my reader where that OL came from by saying it was because there was an OH group on the second carbon, leading me to a name of 2-prop-an-ol. Again, let's try and break down a name and get to a structure. If I have the name 1-hexanol, I'm going to try and highlight my prefix and then see if I've got any weird endings on at the end. Hex tells me I need to be drawing 6 carbons. 1, 2, 3, 4, 5, 6. The an tells me they're connected by all single bonds. So this remaining piece must tell me about the functional group that's attached. I've got OL for alcohol, so I know it's going to be an OH functional group, and I know it's got to stick off of the first carbon. So on your first carbon, make sure that your O is attached to the bond line, and then fill in with hydrogens. And you've drawn yourself 1-hexanol. Naming ketones is very, very similar to naming alcohols. We're going to use a prefix to tell how many carbons are in the molecule, the an to show single bonds, and the ketone ending is ONE to tell the reader that we have somewhere in our molecule this double bonded O functional group. And in this case, that's found on the second carbon. So let's apply that naming structure to this molecule here. I see at the heart I've got 5 carbons, so I'm going to use the prefix pent and use the suffix ane, but stop myself because I know that I've modified pentane and I've turned it into a ketone. So I'm going to use the ketone ending ONE and then tell my reader that I want that functional group put onto the second carbon. So I'm going to call this molecule 2-pent-an-one. Let's break down this name here to try and get to a structure. I'm going to highlight my prefix to tell me number of carbons, look at my ane for single bonds, and then figure out how to deal with my ending. Prop means 3 carbons, connect them all with single bonds, and this one tells me I need the ketone functional group. I don't know exactly where it goes in the molecule, but if you notice, ketones have to be in the middle of the molecule. They can't be at the end because that gives us a different type of class of organic compound. So it has to be in the middle. So I'm going to put it right there on the second carbon. If you're naming this molecule and you call it 2-propanone, that's absolutely fine. You may, although, see it just as propanone because there are no other options for where this ketone functional group can go. Our last class of mobile functional groups is the amine group, and they are actually H+ acceptors, so they're decent bases. Their name is again very, very similar. We're going to have to identify how many carbons are in our longest chain, tell that we've got all single bonds, and then use the ending amine to denote that we're using the amine functional group, which is often going to look just like a little NH2 stuck onto the molecule in some place. In this case, it's stuck to the very first carbon, so our name ends up being 1-but-an-amine. Let's name these next 2. We've got 3 carbons in this molecule, and I know my prefix for 3 is prop. They're connected by single bonds, so I'm going to use the AN. And I know it's an amine because of this NH2 group, so I'm going to put amine on at the end. But in this case, the functional group is stuck to the second carbon, so I'm going to call it 2-propanamine. Let's break down this last name. I'm going to highlight my prefix and denote that I've got single bonds there. Draw in my 3 carbons, connect them with the single bonds. That must mean on the first carbon, there's some amine modification. So let's draw on the first carbon the NH2 group that defines amines. Fill in the rest with hydrogens, and you've drawn yourself 1-prop-an-amine. So again, folks, try very hard and break down the bits and pieces of those names, and you're going to find it's not too bad to get back to a structure, and vice versa.